Operation Research, 12th BM, Transportation Problem. This is a special case of linear programming problem, a special class. Its objective is to minimize the cost of distributing the product from the number of sources, that is, for example, some number of factories, to the number of destination, that is warehouses where all the goods are sold, while satisfying both the supply limits and the demand requirement. So how much demand, we have a demand, so though so much requirement is there, but a supply I cannot satisfy all the demands. So for supply I have only so much limits. So satisfying both, minimizing the cost, is called transportation problem. For example, let us take a source. Suppose some factories are there, F1, F2, F3, F4. Some destination, that is warehouses, where all the goods are sold. From factory 1, I can send my product to the first shop or second or third or fourth. So F1 can transport its product to the warehouse W1 or 2 or 3 or 4. Similarly, F2 can transport, F3 can transport, and F4 can also transport. In total, we have 16 possibilities. F1 to all the 4, F2 to all the 4. Similarly, F3 and F4, 16 possibilities. So we denote that as X11. X11 meaning the number of products which are being transported from F1, the first one. First is factory, second one is warehouse. From first factory to first warehouse. So Xij means what? The number of products which have been transported from Fi to Wj. I have prepared a table. So F11, X11 goods are transferred from here to here. X12 meaning X12 products are transferred from F1 to F2. What is X23 means? From the second factory to third warehouse. X42 means this is X43 and this is X4. X43 means from F4 to W3. Unit transportation cost. So how much it is cost required for such a transport? C11. So cost required for transporting the number of goods from F1 to W1. C22 means cost required for transporting the number of goods from F2 to W3. C44 means the cost required for F4 to transport the product from F4 to W4. So C11 is a cost transporting one unit from, similarly I have written that. So what actually the formulation, how to formulate a transportation problem? So we have to decide some variables which will change. Decision variable. So what is decision variable? X11. So how many products are transferred from here to here? X22, X41, X42, etc. X44. All these are decision variables. So 16 variables in this case. What is the objective of transportation problem? We already saw it. So to only minimize the cost. Which is the cost? So this is the number of products. This is the cost for the product. If you multiply, you will get the total cost. This is the cost per unit. This is number. For example, 1 pen cost 2 rupees means 10 pen cost 20 rupees. This is 1 unit cost for transportation. I have transported X11, so many numbers. So X11 into C11. Plus X12 into C12, etc. X44 into C4. So this is the total cost. We have to minimize this. Supply constraint. What are the limitations I have? So the limitation means if I add all this, X11, X12, X13, X14 must be less than or equal to A1 because only this much is available. So other than that I cannot give. I can promise to give 50 TV. For example, I promise to give 50 TV because I have manufactured only 50 TVs. I cannot promise them to give 100 and 200 TVs because I don't have in my hand. I have availability of A1. So what is the condition? X11 plus X12 plus X13 plus X14 must be less than or equal to A1. Similarly, all this has to be less than or equal to A2. This is equal to A3. This is less than or equal to A4. What is the demand constraint? Demand. D1 is the demand for the first warehouse. So first warehouse have the demand only D1. So they want only, that shop need only D1 products. So X11, from second factory I got some, from third factory I got some, from fourth factory I got some. All this addition must be less than or equal to D1. See, X11, X21, X31, X41 less than or equal to D1. See here, X12, X22, X32, X42 must be less than or equal to D2. X13, X23, X33, X43 must be less than or equal to D3. Similarly, the last one. So that is the demand constraint. So for formulation of transportation problem, we have to minimize this cost. The supply constraint is this and the demand constraint is this. We know all X11 is number of products, so surely it has to be greater than or equal to 0. So I have written the same concept here. Sometimes this may be asked for 2 marks. Write the mathematical form of transportation problem. What is the transportation problem? Mathematical form, we have to minimize this value. Sigma Cij Xij, I is from 1 to m and j is from 1 to n. And the supply constraint is, we know the supply constraint. See, which actually changes here? 1, 1, 1, 2, 1, 3, 1, 4. The second element changes. So j is from 1 to n. This is called AI, availabilities. And the demand constraint is this, which actually changes, the first element changes. So I changes. I is from 1 to m. Okay. So this is a demand constraint. Only if you understand and write, it will be simple. Otherwise, it will look vague. So you understand from the supply constraint and demand constraint and write these 3 conditions. Okay. To solve the transportation problem, we have 3 methods. The first method is north-west corner method. Very simple. You have learned in lower classes. This is north. This is south. This side is east and this side is west. So northwest means the number which is here. Okay. So they have given the problem for obtain the initial value using the northwest corner. Destination, sources, from 1 to A, from 1 to B, 1 to C, 2 to A, 2 to B, 2 to C, 3 to A, 3 to B, 3 to C, and 4 to A, 4 to B, 4 to C. Supply availabilities. I can only supply this. So another name for supply is availability. Availability. This is demand. For warehouse A or for this shop, they have only 7 as the demand. Here only 9 demand. Here only 18 demand. Okay. So this is the problem given to us. Very simple. First we'll see what is the total supply. So available total supply. 5 plus 8 plus 7. So how much is this? 13, 20, 34. This side. Demand is 7 plus 9 is 16, 26, 34. So both are equal. Total supply is equal to total demand. If the total supply equal to total demand, we say that the given problem is balanced one. So balanced transportation problem. So we are going to use northwest corner method to solve this problem. Very, very simple. I have written this one here. That's it. And nothing. Same thing I have written here. So 34 is the total transport and total supply. Okay. So northwest corner means what I have to do is among this box, this is the number which is on the northwest. See, northwest. Okay, you see what is the supply and you see what is the demand. See which is smaller one. In this line, northwest corner is this one. Here I have 5 supply and the demand is 7. Take the lowest one. So 5 is the lowest one. So to this box I assign. So what I have to write? This box means assign. So I assigned 5 to this box. So what I'm going to do now? I have assigned 5. So 5 means you subtract 5 from here. I have already assigned it. I have taken and written there. So 5 minus 5, 0. 5 minus 5, 0. Here, 7 minus 5. What number you have assigned? 5. 7 minus 5, 2. Okay. Now, which becomes, this row becomes a 0. So you cancel these two numbers. You cancel these two numbers. Okay. So just what I'm going to do, I'm going to just hide this number. I don't want, because that row becomes 0. So I'm not going to use that. Now remaining we'll see. Remaining, the northwest corner is number 3. See the supply, see the demand. The demand is 2. The supply is 8. Take the lowest one. 2 is the lowest one. So I assign 2 to this northwest corner. So 2 subtraction 2 becomes 0. 8 subtraction 2 becomes 6. So this side becomes 0. So I close this. So I close this column also. So this is over. Fully 0 it becomes. Now the remaining number. 3, 1, 4, 7, 6, 2. Northwest corner is 3. See the demand. Here it is 6. See the supply. It is 9. Now I have only 6. I don't have 8 now. 6 is the smallest number. You assign 6 here. So subtract. After assigning, you subtract and write. This becomes a 0. After assigning 6, it becomes 3. Okay. So which becomes a 0 now? This becomes 0. So I don't want this number. You close that also. You close it. This becomes 0. Now I got 4, 7, 6, 2. Northwest corner is 4. The supply is 7. The demand is 3. The lowest is 3. You assign. So this becomes 0 now. This becomes, after subtracting 3, it becomes 4 now. This is 0. So I will cancel this also. Now I have two numbers. Above number, north number is 7. So you see here 4, here 18, assign 4. So this becomes 0 and this becomes 14. This becomes 14. Now last number. So this also 0 means that also over. That also over. So I got only 2. I have to see the supply, I have to see the demand. Both are 14, 14 you assign. So this becomes a 0 and this also becomes a 0. Okay. So I have assigned everything. So this is the way we do. Now we'll see the what I have assigned or equal. What I have assigned here, 5, 2, 7. So first number is 7. 6, 3, 9. My demand is 9. 4, 14, 18. It is correct. This is 5. This is 8. This is 7. This is 14. So what we have done is correct. Okay. Now we are going to write the schedule. How it has to travel. How it has to travel from 1 to A. Because I have assigned here. So you choose only the assigned part. 1 to A. Okay. 1 to A. Okay, 1 to A. Then 2 to A. 2 to A. 2 to B, 2 to B, 3 to B, and 3 to C, 3 to B and 3 to C, 4 to C. Okay. Now transportation values. Very simple. 5 2s are 10. 2 3s are 6. 6 3s are 18. 3 4s are 12. 4 7s are 28. 14 2s are 28. So the total cost is 102. So the transportation cost is 102. Transportation schedule is this. Very simple. If you do one or two problems, you will understand very clearly. Okay, so choose the northwest corner and see the supply and see the demand. See which is the smallest. You assign that number to the northwest corner. Then keep on subtracting. Okay, we go to the next problem. Find the initial basic feasible solution of the following problem using northwest corner rule. So this is the problem given to us. We'll see whether the total demand and the supply are equal. 30, 60, 70, 86, 90. Here 10, 20, 50, 60, 70, 76. Then what is it? 84, 90. So total availability equal to total requirement, or we can say the total demand equal to total supply. So the given problem is a well-balanced transportation problem. Hence there exists a feasible solution. So there exists a minimum transportation cost here. So feasible solution. Okay. So we are going to find out how to find the feasible solution for it. Okay, we'll go. How we are going to do now? So first, the northwest corner is number 5. So you check for the first row, the demand, supply is 19, demand is 16. So which is the lower one? 16. So you assign 16 here. You subtract 16 minus 16, this becomes 0. If you subtract 16, you will get 3. Okay. So this side is 0. So my first column is over. Now I got a square box. The northwest corner is number 3. See the supply, see the demand. Supply is 3 now. Demand is 18. Take the lowest number and assign here. After assigning, you subtract. This becomes 0 and this becomes a 15. Now what will happen? The 0 there in the first row. So I have closed the first row. I have closed it. Okay. Now northwest corner is number 7. See the first row, that is this row. 37 is the supply and here it is 15. So you assign the lowest number. 15 I am assigning. So this becomes 0 and this becomes 37 minus 15 is 22. 30 minus 15 is 15. 15 plus 7 is 22. Okay. So this becomes 0. So I will close this now. I got 4 numbers only. Now northwest corner number is 9. See the supply. See the demand. Here it is 31. Here it is 22. The minimum number you assign here. So after assigning, this becomes a 0. So 22 means this becomes 9. Only you have to write the remaining. After subtracting, what number is there you have to write. So this becomes 0. So that row is also closed. Okay. Now among the two numbers. Northwest. So this is west. 7th is west. So see the row and column. Here it is 9. So I am assigning 9. So I have to subtract 9 from here. It will become 25. Now this is over. Since I have assigned, I no need to strike that. Okay. Now this becomes 0. Okay. This becomes 0. Okay. Here 25 for here also 25, here also 25, assign 25. So this becomes 0 and this becomes 0. Okay. Now we'll check whether our answer is correct or not. See, 16 plus 3, 19, correct. 15 plus 22, 30, 37. 25 plus 9, 34. Here it is 16. Here it is 18. Here it is 29, 31. Here it is 25. So our problem is correct. Now I have to write the schedule. Then you have to write the value. Now tell me the schedule. O1 to D1. O1 to D2. O2 to D2. O2 to D3. O3 to D3 and O3 to D4. The values. 16 5s are 3 3s are 15 7s are 22 into 9 9 7s are 25 into 5. The total is this. So the total transportation cost is 580. Very simple. One more problem we'll do. Then remaining we'll do it in the Jamboard. Okay. In exercise 10.1, the sixth problem. Determine the initial basic feasible solution of the following transportation problem using northwest corner method. So from Chennai it goes to Bangalore, Nasik, Bhopal and Delhi. From Madurai it goes to the four places. From Tiruchi also. My total capacity is 90 and 120. Here 30, 50, 80, 100, 110, 120. So the total demand equal to total supply. Given problem is balanced 1. Hence there exists a feasible solution to the given problem. So what is the meaning of transportation? Balanced transportation. Total demand is equal to total supply. Okay. That is called balanced transportation. Okay. Now what we are going to do? Now we are going to solve the problem. Okay. Northwest corner is 6. Supply is 30. Demand is 35. Lowest is 30. You assign 30. You subtract 30. You subtract 30. This becomes 5. You close the first row because I cannot further supply anything. My availability is over. Okay. The next one. Here I got this box. In this box, the northwest corner is 5. So see here the demand, supply is 40. Here it is 5. The lowest is 5. Assign 5. After assigning 5, you subtract 5 from here. Okay. Now, which becomes 0? This becomes 0. So, you leave this column. Okay. Now, northwest corner is 11. Supply is 35 and demand is 28. 28 is smaller number. You assign 28. After assigning, you subtract 28. If you subtract 28, it will become 7. Remaining is 7. Write only the remaining. So this becomes 0. So I will even close this. Okay. Now I got only 4 numbers. 1, 2, 3, 4. Northwest corner is 9. The supply is 7. Demand is 32. So lowest number is 7. You assign 7. After assigning, you subtract 7 from here. You subtract 7 from here. It is 25. So this becomes 0. I am closing that also. Okay. Now I got 2 numbers. Now the west number, northwest. Among the 2 numbers, this is the west. So 7. Here it is 50, here it is 25. I am assigning 25. After assigning 25, I have to subtract 25 from here. So this is 25. Over, don't cancel it. Now the last number is here. So here 25, here 25, assign 25, subtract 25. Okay. See? Now we'll check whether our answer is correct. 30 capacity. Here 28, 35, 40. Here 50. Here our demand is 35. 28, 32 and 25. So our problem is correct what we have done. Now we have to write the schedule. Then we have to write the transportation cost. Schedule is O1 to D1. Yes. O2 to D1, D2, D3. O3 to D3, D4. Okay. The transportation value I have written. 30 into 6, 180. 5 into 5, 25. 28 into 11, 7 into 9. 25 into 7, 25 into 13. The total is 1076 cost. The transportation cost. So this is the method by northwest cornering. Thank you.